Have you ever really thought about what it takes to bring a server to life? It's not just about flipping a switch. It's this whole fascinating journey, taking a simple metal box and turning it into the powerful backbone of our entire digital world. So, let's dive in and see how it's done.
And our story starts right here. A brand new server, fresh out of its packaging. I mean, look at it. It's packed with potential, but right now, it's basically a very expensive, very powerful paperweight. It can't do a single thing. No power, no network, no purpose. It's just hardware waiting for a soul.
And that's the million-dollar question, right? How do we take this inert piece of metal and transform it into a living, breathing part of a data center? Well, the whole process is this really cool dance between nuts and bolts physical work and some serious digital wizardry.
First things first, we've got to give our server a home. And this isn't just any home. It's a super organized, purpose-built environment. The first official step is called rack and chassis mounting.
It starts obviously with unboxing, but the really crucial part is the mounting. We attach these special rails to the rack, and then the server just slides right onto them until it clicks securely into place. And the really clever thing here is that most of this hardware is designed to be totally foolproof. The rails, the connections, they only fit one way. It makes the physical setup surprisingly straightforward.
So now the server lives inside a rack. The best way to think of a rack is like a skyscraper for electronics. A standard one is 42 up or units tall. That's about 6 feet of high-tech real estate, all designed for perfect organization and, super importantly, airflow.
But a rack is never empty. Our server has some very important neighbors. Way down at the bottom, you've got the UPS, basically a giant battery that keeps everything running if the main power ever goes out. Along the sides are the PDUs, which are like the most industrial-strength power strips you've ever seen. And up at the very top, the top-of-rack switch, which is the gateway connecting every single server in that rack to the network.
Okay, our server is housed securely. Now it's time to plug it in. And this isn't like plugging in a lamp at home. This is a precise art, connecting our server to the data center's entire nervous system.
Every single cable here has a critical job. We plug in 2 power cords, not 1, but 2. That's for redundancy, so if one power source fails, the server doesn't even blink. Then come the network cables, its connection to the outside world, and maybe most importantly, this special remote management port. It's called an ILO or an iDRAC, and that, my friends, is the secret sauce to controlling this machine from literally anywhere.
So you might be wondering, how do you manage hundreds of servers without having hundreds of monitors and keyboards cluttering up the place? The answer is this brilliant device called a KVM switch. It lets an administrator use just one keyboard, one monitor, and one mouse to control any server in the rack just by pushing a button. It's a massive space and sanity saver.
And now for the magic moment. This is the point where we transition from doing all this physical, hands-on work in a noisy, freezing cold data center to controlling everything from the comfort of a nice, quiet desk.
So here's the handoff. We press the power button, we watch the boot screen pop up on our KVM monitor, and then we do one last crucial physical task. We give the server's remote management card, that ILO port, its very own unique IP address. Once that is done, we can walk out of that data center and probably not come back for a very long time. From now on, everything is remote.
This is the incredible technology that makes it all possible. An ILO, or iDRAC, is basically a tiny independent computer that lives inside the server. It has its own little processor, its own network connection. This is what lets us power the main server on or off, install an operating system, and troubleshoot problems from anywhere on the planet, even if the main server has completely crashed. It's a lifesaver.
So our server is now a blank canvas. It's fully powered, it's connected, and we can access it from anywhere. Now it's time to decide what it's actually going to become. It's time to give it a job.
And this is a really critical moment. This is a fork in the road. Is this server going to be a specialized workhorse dedicated to one single heavy-duty task? Or is it going to be more of a versatile multitasker juggling dozens of different jobs all at once? The choice we make right here defines its entire life.
The 2 main paths are to make it a physical server or a virtualization host. Think of it like this. As a physical server, it's a giant factory built for one big job, like running a massive database. But as a virtualization host, it's more like an apartment building. It runs special software that can host lots of smaller, independent virtual machines, and each one can have its own purpose.
Now those are the 2 paths for setting up one server. But What about the hyperscalers? The huge cloud companies. They can't possibly set up servers one by one. They use a highly automated method called PXE boot.
And here's how that works. With PXE, a server doesn't need a USB drive or an installation disk. The second it powers on, it just broadcasts a question out to the network that basically says, "Hi, who am I and what's my job?" The network automatically answers, feeding it the right operating system and a complete list of instructions. This is how thousands of servers can be built in a single day with zero manual intervention. It's mind-blowing.
Okay, so whether we went the physical, virtual, or cloud route, our server still isn't quite ready for the real world. We need to build its foundations and put up its defenses.
Before we even think about installing an operating system, the very first thing we do is configure something called RAID. It's a clever way of grouping a bunch of physical hard drives together so that if any single one of them fails, absolutely no data is lost. It's the server's built-in insurance policy for its data.
All right, now for the OS installation. Now, instead of just dumping everything into one big digital bucket, a professional setup divides the storage space. Think of it like building a house. First, you'll lay the foundation. We create a small, dedicated space just for the essential files the server needs to boot up.
Next, we build the main living area of the house. This is where the operating system itself will live. And we use a flexible technology that acts kind of like movable walls. So if the OS needs more room later on, we can easily expand the space without having to tear everything down and start over.
And finally, maybe the most important step, we build a completely separate, secure vault just for the application's data. This separation is a critical principle. It means that if the operating system ever crashes and needs to be reinstalled, all the precious data is safe and sound, untouched in its own room. It makes recovery so much easier.
With the OS installed, it's time to harden it. We lock it down. We configure a firewall. That's the guard at the gate. We install systems to detect any intruders. We enforce super strong password rules. We even disable physical things like USB ports to prevent anyone from just walking up and plugging something in. The whole goal is to make this server a fortress.
The physical work is done, the software is installed and configured, the defenses are up, our server is finally ready to do the job it was built for. And with that, we flip the final metaphorical switch. The server is officially in production. It's serving websites, applications, and data to real users. Its long journey from a simple box to the backbone of a service is complete.
But really, its life is just beginning. Now, the team that built it hands it over to a tiered support team. You've got Level 1, who are like the night watchmen, monitoring it 24/7. Level 2 handles the day-to-day stuff. Level 3 gets called in for the really complex problems. And Level 4 are the super specialists who investigate major failures to make sure they never, ever happen again.
So, we just walked through that whole meticulous process. The unboxing, the racking, the cabling, the software, the hardening, for just one server. It really makes you think, doesn't it? If that's what it takes for one, how on earth do cloud giants automate this entire flow to deploy thousands, tens of thousands of new servers across the globe every single day?